right, let's go. All right, Aaron. There you go now. Arian. All right, so what is wave particle duality? This is basically given like two separate properties. All right. Now, Leah, where did we get it? Where did we get this particle nature of light from? So initially, remember, we know light to behave as a wave, right? In interference and refraction and diffraction and thing, right? Where did this particle property come from? Where did the idea of it being a particle come from? Just did it. We just did it earlier. Where it came from? Photoelectric effects, right? Right? Photoelectric effects brought about the particle nature of light. Okay? And this guy here named Broglie, right? He was able to predict that light could exist both as a particle and a wave. All right. So let's take a look at that and let's look at how we showed it, right? So to explain some aspects of light behavior, such as diffraction interference, light is described as having wave properties. But for aspects such as the photoelectric effects, we describe light as having particle properties. Therefore, light exhibits wave-particle duality. Okay? Wave particle duality is not confined to light alone. Every object has it. So, for example, this phone, looking like a particle, right? But it also has wave properties. But the particle properties are more prominent. Okay? And I will show you by a calculation, right? All objects from electrons to footballs. The behavior of relatively large objects is dominated by particle behavior, although they exhibit wave properties. Okay with that? So every single object has both wave and particle properties. In 1923, Louis de Broglie predicted that that's not the right pronunciation. I do I just say right. Yeah, I think it's the yeah, there's forgetting. Why is it different? Right? In 1923, Louis de Broglie predicted that since light exhibited both wave and particle. Right? Both wave and particle properties. Particles should also have both wave and particle properties. So what you're saying? Right? You all remember that, right? You all remember that E is equal to MC squared and E is equal to theta, right? And F is equal to what? Right? B is equal to F lambda. B is equal to F lambda, right? So therefore F is equal to B on lambda. Why do we use C? Speed of light, right? So therefore, MC squared is equal to H on C lambda. If you rearrange, you will end up, C will cancel, and you'll get MC to be H lambda, or you'll end up with lambda being equal to H over MC, and MC is mass by velocity, which we call momentum. So, what you recognize here, Arian? We have a wave property having a what? A wave property having a particle property. So you recognize here that wave and particle exist together. You'll see that? Lambda and mass exist together. Right? And that is where the wave particle duality comes from. Everybody okay with that? So if you see a question and the question says, find the de Broglie wavelength. They're talking about this lambda here. lambda is equal to H over MB, right? Because it will vary from substance to substance, right? You okay with that? So if I ask you to find the Broglie wavelength, what's called H again, Saraya? Right? M is the mass of the object and B is the velocity of movement with.
The shape of the value is 6.685 times the mass of the equal. 3. This 3. Okay.
All right. So his prediction has shown to be true when beams of electrons and neutrons were directed at crystals at diffraction gratings were obtained. Patterns were obtained. This is evidence of wave properties of these particles. Everything has wavelength, but the wave properties of matter are only observable for very small objects, right? So if you look here, look at these two calculations, right? You don't have to do them over. Right? What is it? Right? Find the wavelength of a pole of a mass moving with that speed. When I say that, yeah. Plug in your values. What you recognize about that wavelength? Extremely small, right? It's not observable at all. Okay, so it's extremely small. Nikolai, I'll do it semester. Yeah. All right. So the wavelength is extremely small. So what you're seeing here is that a ball has wave properties, but the value is extremely small. Right? But look at our electron. An electron moving with that speed has a wavelength that is much smaller. That's okay? Right? And of course, it has a mass as well, right? The electron has a mass. All right, let's do a past paper 2006. All right, let's go fast. Oh yeah, write the answers down for that fast. Right, the can't shoot. What's the first equation there?
E equal to HC on lambda.
Yeah, right.
So study it.
Next one, Aaron. E is equal to, without looking back, see if we can find the Broglie wavelength fast. Without looking back, derive the Broglie. Make lambda the subject and the formula. Oh yeah. Put it together fast, please. Ready? Well, yeah, guys, not this brutally. I'll just say that brutally, right? Right. Correct thing is this broad. The broad. Yeah, broad, not the broad. The broad. Not the broad, not the broad now. The broad, right?
Like the royal flag are.
It's like is
We don't have orals.
BROL.
We don't have orals, so we don't have to know what the correct is.
The broad. Follow you again on again some of the little tea.
Oh my God, so the second one.
And now I'm gonna get to that.
Right. Well, I got you.
Yeah.
Right, we are reading the field.
Yeah, we do that already. Lambda is equal to.
Right, so you just say making equal,
Lambda is equal to h over m6.
right? So you'll get lambda is equal to h over m. Nice. Next part, find the Broglie wavelength. Two parts there. Hurry up. No, show on this. Go back.
So you raise everything on your screen now. That's it. You raise everything on your screen now.
No, I don't. Yeah.
Right, take your time and work it out, right? Well, you have to put in the 411, it's the cash course, right? Right, take the one then. Yes, Let's tell them what.
Yeah, this one.
Yeah.
It's
Five. Y'all done?
Because the mass of election.
Boys, you guys are election. Excuse me, my. Not coming back from
this year right here.
Yeah, right away.
How many units?
I way after.
It's a raya, what's a raya?
So this item the shot.
Why did you give here? Why did you give me
Why they give us gold? I don't know, we'll see. How you getting speed then? How we getting speed from voltage?
Easy for the F lambda. Easy for the F lambda.
Think about it.
I never.
Everything.
I think you can play.
Right, so we know that,
Alright.
we know that lambda is equal to H on MC. We know H, we know M. So what we have to do is figure out how we get the speed from the voltage.
What does that mean? Speed of light? No, it's an electron.
No, it's the electron. Not speed of light, huh? F is equal to V on lambda. No. Anybody have an idea? Any ideas, Olia? How we can go from voltage to speed?
Can use
Think about what the voltage will do. Anybody online either? Yeah. Any ideas?
you want 1 point.
Just keep quiet.
And I like the roof.
What's up with it?
Alles für Entscheidung.
Right now, Sarah, this is the one.
Alles für Entscheidung, was ich auch will.
Right now, Sarah.
It's
Right. Wait, come up with.
Sorry, Jason.
Alright, so if you have voltage, right? So if you remember, we did this in we did this in unit. Alright, anyway, if you have voltage, right? And the voltage will give the electron some energy. Or you'll go from voltage to energy by E, right? So if you multiply Q by V, remember that? Right? So if you find the energy by multiplying the charge of an electron by the voltage. So if you have the energy of the electron, how can you find the speed of the electron? Huh?
Is equal to MC delta theta.
Right? So we can use a half mv squared. Right? It will have connected because it's moving, right? And you make V the subject of the formula. Try that fast.
What's that E to the 1B? No, it's not E to the 1.
Huh? Yeah, the energy is equal to Q by V. Oh, yeah, without. Right, so work out mass of the electron. Right, what you all got for that? Mass of the electron is 9.11 by 10 to the minus 31. But it's speed. Big. 5. So big. Why you get to the speed here?
Point draw 6 by 10
Minus. What you use as the mass of the electron?
9.1 by 10 minus.
Minus.
He wasn't there. You did not say
Yeah, I get put you. The example. Yeah, example. 4.3 by 10.
Sorry.
Yeah.
Again, by 10 to the 7.
Yeah.
Right? Remember moving fast, close to speed of light. Right? So it should be around that, right? 4.31 by 10 to the 7. Anybody do it?
I think
Bring it next week now.
That's so much Fridays. Would it happen February 2025 and 2029? Yeah, but it's not.
Yeah, remember the last one?
what I want, I don't want.
the times when I'm program. He did. Yeah. No, but actually, I'll probably give it to me.
Sorry, go ahead and done. Yeah, no, we should have done. That's financially.
15% of the
Like 9.6 or 9.9.
Yeah. So I was given it all that.
Oh, yeah, I usually roll. I usually roll lots of that. So, and I was the biggest guy I think you score.
6.63 by 10 to the minus 34, right? 9.11 by 10 to the minus 31. And the speed is 4.31 by 10 to the 7. How much you all got now? 1.69 by? Nice. That's right. So it's good that I recognize that the value was too large. So you have to go back and check it. Anybody get our online? 1.69 by 10 to the minus 11.
And my voice. I started.
To the next one, find the frequency. 10 to the minus 11. Sorry.
Yeah, we should change our secret.
Yeah, no, you see in the proof, you see. That okay with that, right?
So it is 1.69 by
1.69 by 10 to the minus 11. Minus 11, right?
Yeah.
That's all, yeah? Yeah. It should be a little smaller than light, right? Light is normally be around minus 7. What? Alright, let's go again. Yeah, part underneath. Okay, 3.6.55 by 10 to the power 18.
Yeah, you say that I'm proud of
Right, so an oscillating molecule, the excites from one. Oh wait, I didn't show you this earlier. The molecule goes out this. Calculate the frequency. What is this here? Electron volts, right? So that is your energy.
I thought I stop your potential.
That's
So when I see you stop your potential.
a unit for energy, yeah. Potential is voltage.
I need to get a
Right, so we had to convert electron volts to joules. How are you doing that?
was divide by 1.6 by 10 to the minus second.
Divide or multiply?
Multiply, sorry.
Multiply by 1.6 by 10 to the minus 19. And if we have the energy, how we get frequency? E is equal to what? Right, E is no, as long as I always, since the beginning of the class. Not the correct number. Very good.
I don't know.
Very good. We got that somewhere here for the frequency.
I go by frequency.
We get 2 point.
Yeah, I get 80. Yeah.
Yeah, it should be around that. Should be around 14.
I could get it wrong.
5.31 by 10.
Yeah.
I think it's 14. Check it back and see.
I use
5.31 by 10 to the 14.
I use B because I have problem.
Huh?
I use B because I have problem. The reality.
So this is our next really question. The one on top is an electron, the one below is a different molecule. All right? Not the same thing, right? Not the same thing. But okay with how to find the Berkeley with wavelength? Sorry. I can't remember. I can't remember the word. Broly. Yeah, Broly. Alright, let's go again. Wait for what? Try 35 fast and 36. Multiple choice.
What else for it?
If you all remember, right, based on the crash courses from last year, where you all want to change the or less of.
I don't get, you know, I'm last year, it's not cash course. You see, I'm not cash, but when you start one size like two cash really, like it's really tough, right?
Right now, we're doing crash course. Yeah. Huh?
Yeah.
Yeah, but I don't like that. I way down in the end.
No, but cash, but it's now.
Yeah.
Then maybe class 3 hours and giving like 50, that's great, but only one. You know, serious things after that 2 hours, like I want 1 point, that's not. We just can't. We just can't see us. Then I think I'm fine.
Oh, 35. Well, again. B?
Yeah. I get 36, I get 36.
35. What again with 35?
36.
So lambda is equal to what? H over. Right? And we have M and we have C. So what again? Boy. Yeah. Right? By looking at the answers, you know E and D out, right? Because they always have two close answers. And the only two that close to be B and C.
What if the change?
That's general,
Yeah.
general, right?
That's
It's like if you don't know nothing and you want to narrow it down and get a percent chance, you can apply that. Or do something. Last one. Shirish, 36 is what? Huh? D. Correct. Did you have same thing, right? Same thing?
Yeah, 60 after.
36 is what? Timothy, where you get it? 36. Why C? Huh? Are you saying C? Right? Particle nature is the photoelectric effect, right? All right, nice. That's it for that. Next one, I should probably give all the one for you.
Yes, yeah.
After this.
Hey.
Right side of Milikan's oil drop. Milikan oil drop experiment. No, we're not there yet. All right, ready? Right, so here's the gist of what he did, right? We already know after. Right? Here's what Milikan did, right? All ready? So in summary, here's what he did. Milikan was able to show that all charge is a multiple of E. Right? So you show that all charge is a multiple of E. So if I give you an oil drop and it has a charge Q, that charge Q is some multiple of E, small e. Right? Small e is charge of an electron, right? So basically what he kind of saying is that all these charged particles have a certain amount of electrons on them. Are you okay with that? So what he also suggested here was something called right? Something called quantization. So he suggested that all charge represents in quantities of E. So it might be 5 quantities, it might be 6. But he suggested quantization. And what quantization suggests, yeah? Right? So what quantization suggests? It suggests particle nature. When I think of particle, what do you think about?
Electrons.
Quantities, right? Right? So specific masses of something, right? So this is particle. When I think a wave is something continuous. All right. So what Milikan was able to bring about again was the particle nature of something. All right. So watch this here. Here's what he did. He took an oil drop and he allowed the oil drop to get a charge. Okay. By allowing it to become atomized by getting electrons on it. Then he took that charged oil drop and he allowed it to go into an electric field. All right. So right now, what you have acting on it is what? It's the weight, right? Yeah, it has upthrust as well, right? But let us ignore. Oh, you should put all, boy.
External forces.
Let's ignore upthrust for now, right? Actually, I like to put all, and then I will show you why we would ignore it. So right now it has upthrust, right? And it has drag force right now while it falls. All right, but the charge here is negative, right? So what would happen if I turn on the plate and here becomes positive? What will happen? Well, it won't move as yet, but there will be an additional force called the electric force acting on it. All right. So what he was able to do, he was able to adjust the voltage here, right, until the particle became stationary. That's okay. If the particle is stationary, what are the forces acting on it? Weight. It should still have upthrust, right?
Yeah.
And what else? The electric force. No drag force, right? Because it's stationary, it's not moving, right? So it only has weight, electric force, upthrust. Right? Right? So as I was saying that so when it's stationary, all these forces here equal, right? But if the upthrust is negligible, then we can say that the electric force equal to the weight, right? And the reason why it's negligible, anybody remember how to find upthrust? Upthrust is what? Right? Upthrust is equal to weight of fluid displaced, mass of the fluid by gravity. Remember that? No height, no. And upthrust is density of the fluid by gravity, by volume, by gravity. Remember that? Even if you don't remember, right? The upthrust is really, really small because the density of the fluid when compared to the oil is negligible. So we ignore this. That's okay? So if we ignore somebody just pulling it off and so if we ignore the upthrust, the electric force equal to the weight. That's okay? Anybody remember how to find the electric force? No. No, like remember all this stuff. Show him, you know, martial song word for word. You know, martial song word for word. Yeah. Anything? Yes. Somebody studied that now. What's the electric force? Carry on. Remember the electric force? Nalia? Arian? Yeah. EQ? EQ. Right? Electric force is electric field strength by charge. And what is electric field strength? Yeah, E is equal to what? Electric E. The E. Capital E. Oh wait, I know we have to make one right now. Yes. Yeah, we have video. Yeah. Anybody remember? How you find electric field strength? Look back fast, look back. Not much, not too far away.
Q1.
When I look for it,
Beyond
right? Electric field strength is the potential difference divided by the distance between the plates. Right? So what's this here? So you have BQ1 P. So you can carry across this and you'll get Q is equal to mgd all over V. Are you okay with that? And this here, you would recognize when you work this out, this will be some multiple of V. So when you work out this, you're going to be some multiple of V. Hi, Wyatt. Please remember these things all, yeah? Then you know what to take it out because you're going to use it now.
Creating a pariman kita Wednesday. Watching to. Why? Ya no pasa, lo que pasa. Ya me pasa en March.
And ready? So that was the just behind the Milikan, right? So when you perform that calculation, you should get some multiple of it. Right? What do you guys think?
Yeah, no.
Yes.
To be sure, how do you screen look at Gloria? It's okay. How do whiteboard look at? Glory?
Ya, pura tang chot lah.
Yeah?
No, I just smell like a virus.
Yeah.
There you go.
Ignore. Right? We ignore that because it's negative trouble. Are you ready? Just take a look at this. Right, so I just reading through the experiment, everything I talked about. Right, an experiment performed by Robert Milikan at 1909. So I wanted to the reason why I kind of highlighted the years. You remember when they probably recognized the wave particle duality? So it happened after, right? So Milikan was one of the persons who kind of put into Einstein's head that the problem with the photoelectric effect was that light could have possibly be viewed as a particle, right? So because of this small experiment, he started to introduce the idea of that particle nature of light. Right, Ida? I just put a note together, so it might make some sense because there is one question that asks you who contributed to the particle, yes. And they had it separated, Einstein alone and Milikan, and supposed to be them together. Right? But the answer that they want to was Milikan. Einstein. So an experiment performed by Robert Milikan in 1902 determined the size of a charge of an electron. He also determined the smallest unit of charge at E. Nikolai, you want to read it? Stay quiet now. Right? He received a Nobel Prize for his work. He used the following apparatus to put a tiny charge on a tiny drop of oil and measure how strong an applied electric field had to be in order to stop the oil drop from falling. All right, so that's technically it there. You've seen it? It's pretty oil, and it's labeled. Right? You gotta be able to label everything, the oil drops, you have the field, it's showing you how to ionize it, and it shows you how everything works, right? An atomizer create a fine piece of oil drops into the chamber. Some of these tiny droplets fall through a hole on the upper floor. Pelican first let them fall until they reach terminal velocity and use a microscope to measure its terminal velocity, and hence by the formula calculating mass. All right. So he was able to do that initially to find the mass of the oil drop. The electric field, Next, Milikan applied a charge to a boiling drop by illuminating the bottom chamber with X-rays. This caused the air to become ionized and the electrons to attach themselves to the oil drop by attaching a battery to the plates above and below the bottom of the chamber. He was able to apply an electric voltage. The electric field produced in the bottom of the chamber by the volt would act on the charged oil drops, and if this voltage was right, the EMF would just balance the force of gravity on the drop, and the drop would be suspended in midair, right? Notice I don't have object here because the object was too small, right? So we ignore that. Right? Same calculation here, and we arrange it here and a sort of Q. Right? Same calculation, right? I just introduced E as being beyond. That's okay? So if they ask you to find the electric field strength, you need the voltage and divided by the separation of the plates. Okay? So here we have a small example. I want to read it and show that charge quantized. So when you work it out, I want you to find the value of Q. Okay? Try it fast now. All right, some other way to the hand out. All right. So if you watch here, try it and see. I can take the hand of my phone. Try it and see. The Kahoot expired. Yeah, 7:20.
I look at you.
Oh yeah, work out this fast. Work out this fast. Two parallel plates. What's that value there? 3 by 10 to the minus 2. That value is 3 by 10 to the minus 2. What does that represent, Divish? You only want to 3 by 10 to the minus 2. But let's say that's the formula. D, all right, nice. Right, held horizontally, they give you the upper plate, they give you the voltage at the upper plate, and they give you the mass of the oil drum. Right, do we need anything else? We have MQ, we have M, we have G, we have D, and we have C. So I can see some way again, huh? Pretty much like it. Sure. Very aware that it have the mass, gravity. No, this formula on this board, I substitute what E was. The one there I didn't. I will got E separately. Right, same thing. I just did not. Work it out. You all got that? 6.4. Yeah. So how many electrons on that how many electrons trapped on that oil drum? Right? Divide by 1.6 by 10 to the minus 19 and you'll get 4. That's okay? Right? Do 2008 numbers. Wow, they are fine. Okay, so that is the Milikan algebraic experiment. Well, okay with that? But when you work these things out, you're supposed to get exact values, huh? Let's try 2008. Let's see oil drum. Can you all see better? This one? What's on the others? Wait, that's full screen.
Sir, wait, come on, sir.
How about this one?
Okay.
Right, here's one. I got to zoom in some more. You all know what you have to find, right? Find the tiny charge and how many electrons on it. Oh yeah, just like what you just did. Right, this is 2008.
After this, we do it.
Yeah.
It doesn't exist. It's not there.
The consequences will happen.
Oh yeah. Huh? You have to calculate the charge on the oil drop and how much electrons are it.
I can say I can find a way of this.
Right? Join the forces, find the
Just go.
pretty well, small. No, it's from my. Look at this.
So that 9.5 can be minus 15.
9 point what?
There you go, brother.
Necessary sacrifice. What's that?
Okay, we're not hanging, it's not hanging.
Ito ba rin?
Ito, very chair. You sure? Yeah, I'll see it. I'll see it.
This chicken?
Yeah, I'll see it. Just show me. I'll give you the next now. Yeah. Well, let's talk about this. Someone? You're not seeing it. Well, is it a house of church? Well, what you got one like this? Well, I'm wondering why that's not here. But you're trying to violence. Yeah, I think it's on. Well, something that you will get money. Nah.
So, you know, while it's high school, they don't even make any money there. Well, they have people normalize them. Oh, everybody, the big. You know, one thing. In every school. Actually, not whether you
You know what you're joking, right? Don't do it. Don't do it. You mentioned on your please. Oh, so no, 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 like it's from there.
Alright, ready? After you find Q, you have to find the number of electrons on it. On the picture, you can come out.
I can say 5 electrons.
Tell them to look for.
That is 5 electrons. So 6.
How much are they get?
6 electrons.
How much you get online? Well, Tavisha got 60 electrons. But I get that to 9.6. Banaya, you work it out. Work it out, please, Banaya. Oops, what's Banaya? Don't know who it was, Banaya will be. He's talking about Banaya. Finish. But now. Yeah, I'm gonna do it now. I just wasting on now. I wait, I'm Cairo. And I'm here. And Timothy, you talk about that? Let me see.
So, yeah, this is 2008. Right, we got off the right? Right, that question is on the next part, yeah, but let's look at the first part here. So what's here? Right, so this is the 2008 number 6, right? They want us to find Q, same formula, Aaron. Same formula. Mass was what? 9.8.
Right, gravity we use as 9.81.
9.8.
Right, and the T was what? 1.5 by 10 to the minus 2. And all the voltage. So when you work it out, you're supposed to get 9.6 by 10 to the minus 19 coulombs. So look at that. Sean? So look at that. Right? It's supposed to be minus 19 here. I can make sure.
Right? And then if you want to get the number of electrons, all we have to do is take 9.6 by 10 to the minus 19 and divide it by 1.6. And you're supposed to get 6. So you have 6 electrons. That's okay? But the question has more to it. Right. Here's what happened now. Take a little read on the here. Y'all seeing that? Right. Saraya, here's what happened, right?
Yeah.
The potential of the upper plate now is now negative. Right? Negative 1.5 by 10 to the 3. Determine the initial acceleration of the charged drop. What will happen to the electron? I mean the oil drop. It'll go up what?
Because it.
Yeah.
Because it's negative. Because it was negative. So it will start to go what? It will start to go down, right? So it will start to go down, right?
Wait, so which place?
The oil drop is negative. Right? The top is now negative, the bottom technically positive, right? Right. How we go and find acceleration? Huh? B squared equal to? Number we do our best. No, no, we don't know what it was. We're not sure what it was. And if it was in the middle, it was stuck in the middle like so. Yeah, sorry. How we doing that? How we getting the acceleration, the initial acceleration is equal to what? F1m, very good. Right? We know the mass. We know the mass, but what will be the forces acting on it? That's all? No upthrust. The electron force. The electric force. Right? So the electric force pulling it downwards. So the F would be the electric force plus the weight by mass. Okay? So you have to work out that now. Right, so think about it. Think about when we were doing that, right? If you talk about positive and the electric force at upwards, it means that the charge has to be negative, right?
Yeah.
So if I change it up to be negative now. So the resultant force acting on it now is the right? So now you have weight and the electric force acting on it. Same formula. Same formula you have there. Electric force is what? How you find electric force again? Beyond that electric field. Electric field strength multiplied by charge. But we know the charge now? Come with charge, right? 9.6, right? And then add it to the weight and divide by mass. Some more again. Same weight, nothing changed, right? The weight didn't change. And we can actually find the electric force now because it's moving downwards. Right, Sean? What do you think now? The cube of the electric force we can find mass. Right, yeah.
Your answer is
No,
no.
I don't think of-
Well done, Nalia, excuse me, you open it out? Yeah, be honest, yeah, those are, pay attention. Second one, what modulators? Oh yeah, book it out fast. By finding electric field strength
How much that?
beyond the,
About that.
huh?
About that.
Same thing, 1500 divided by 1.5 by 10 to the minus.
I can make number.
Wait, who said 10 to the minus 3?
Yes, I think minus two.
10 to the minus 2.
Yeah. This is one of the street coming to.
Right? It was 1.5 by 10 to the minus 2. It's centimeters, 1.5 centimeters. Should that was the answer.
Okay. I'm finding out, sorry. Like,
Right?
yeah,
So-
that's what he said.
E is the same thing, 1500. I just plug in the values here, right? Come on, what you get for it? Right, it's still 1500 divided by 0.015. Charge was 1.6 by 10 to the minus 19. How's the mass again? 9 points, 9.8.
That's what he said.
And gravity is 9.81. How much did I get? Yeah, 19. 9.6. Try one.
I did.
Someone else ain't seen that.
Exactly. Like, it's like-
The way we do, you will stop coming to us and you will sit down there. Yeah, from now on. When I have the question, I have to get that out. When I come next, when I have the question, what do you say? Everybody okay with that? Iran, follow and on. All together values. Can't you all together?
Yeah, everybody get it.
Last one. Try this please. Last one. Nalia, it would be nice if you could do this one for us. No, nobody else, but please. In fact, come on the board, Nalia, work out this. Work out this one, please, Nalia. Hurry up. Last one. Right, they gave you the electric field strength here.
Like, what's still gas?
They gave you the electric field strength. Hurry up. No, you know, working it out? It should be in your hand working it out. Tyra, let's keep your hand up, my left, I'm working it out. Give it to you. One second.
Oh, great.
Right, the right. Ah, I love see. Keep it, you know, working it out. Right, so it should be 4 by 10 to the minus 15
By 9.4.
by 9.81 all over
4.2 by 10.
4.2 by 10 to the 4 because they gave it C, so you gotta work it out. How much is that?
6.
Alright, well,
But you go last third one. 12 by 10 to the minus 9. What was the value?
5.83.
Huh?
5.83.
9 point?
Yeah.
No, what is the value?
9.3 right there.
9 point? 9.33, okay. And then you divide it by 1.6 and you got what?
5.8.
5.8. Alright. And if you use
So we are getting.
huh? No, you have to divide that by the charge by electron. Right. Okay. Online, are gonna be alright, nice. I don't like that's it. That's it.